So what we are going to look at today is arithmetic growth and decay, generating number patterns. So we're going to look at real life scenarios that you can use arithmetic sequences in. So BP Birthplace Forest program is in Calgary, and what it does is it enables parents to honor their children by planting a tree when their child's born. Shows concern for the urban environment, and some of the trees that have been planted, they've been growing for the last 15 years because the program started in 2000. Trees, or some of the trees that have been planted, are evergreens, which grow on an average of 12 to 18 inches per year. So an evergreen tree 6 inches high was planted in June 2000. It has a growth rate of 15 inches per year. 2 students were asked to determine the height of the tree in June 2011. Joel formed an arithmetic sequence beginning with 6, 21, 36, and Jenna formed an arithmetic sequence beginning with 21, 36, 51. Use the formulas in the previous lesson to determine each student's answer to the problem. So if I look at Joel, how many years have passed? Or if I look at the number of terms from the year 2000 to the year 2011, how many terms would that be? It would be 12. So n would be 12. My first term would be 6. And what's my common difference? 15. So T of 12, which would be the height of the tree in 2011, would be 6 plus 12 minus 1 times 15, or 6 plus 11 times 15, which would be how many inches? Now, because Joel and Jenna are working on the same problem, when I'm done Jenna's calculations, I should also have 171 inches. So with Jenna, what's the first term of Jenna's sequence? And what's her common difference? 15 as well. What is her n going to be? Because 21 starts in which year?
Wouldn't that be like after the first year?
After the first year.
So then it only be 11.
So then her n is 11. Good. So then the 11th term of Jenna's sequence is what I would be looking for, and that would be 21 plus 11 minus 1 times 15. 11 minus 1 is 10 times 15, and I get 171 centimeters. Or sorry, not centimeters, inches. So in the next part, what we're going to do is determine the formula for the general term. So I'll start with Jenna's and then I'll work back to Joel's. So in Jenna's, if we use our formula, that's our formula for an arithmetic sequence for the nth term. The general formula is the nth term. So A is 21, N is my unknown, and D is 15. And then I clean up my formula by removing the brackets and collecting like terms, and I get 15n plus 6. If I do the same thing with Joel, using his variables, or the values for his variables, A is 6, D is still 15, so I get 6 plus 15 and minus 15, So Joel's general formula is 15n minus 9. Why are these two formulas different? They have different first terms. So the first terms are different. And because the first terms are different, what it does is the values of n have different meanings in each, or for each person. So for each formula. Because the n here is kind of including that year 2000, whereas the n for Jenna's is after the year 2000. So in Jenna's formula, if I wanted to determine the height in 2015, I could plug in a 15 into that equation. Whereas with Joel's, if I wanted to determine it in 2015, I'd have to add 1. I'd have to think of it as being the 16th term. Whereas Jenna's is more so the 15th year. So if the tree continues to grow, in which year will it reach a height of 28 feet? So if I take Jenna's formula, I want a height of 28 feet. First of all, what are the units in my formula? Inches. So I need to change this 28 feet into inches by multiplying it by 12. And what do I get?
336.
So 336 will equal 15n plus 6, and then I'm going to solve for n. So what would I do first? That would leave me with 330. And then, and when I divide by 15, what do I get? 22. So it would be in the year 2022. With Joel, if I use his formula, I get 336 equals 15n minus 9. How would I solve this one? And that would give me 345. And what do I get? 23. So what do I need to remember to do if I have Joel's? Not add 1. I have to take 1 away. Because for Joel, n equals 1 in the year 2000. So if n equals 23, it would have to be the year 2022. So I could solve this equation either way. I just need to be certain that I know what the n represents. Does n represent the term number, or does it represent the year? In Jenna's case, it represents the year. In Joel's case, it represents the term number. In the 23rd term is 336. The 23rd term is in the year 2022, because the first term was the year 2000. Are you okay, Dylan? Okay, next example. Printing press is bought in the year 1992. It depreciates in value by the same amount each year. So 5 years after it was bought, the printing press had a value of $311,000. It had a scrap value in the year 2010. What does scrap value mean? basically you're selling it for whatever parts or whatever they can scrape off the machine. It's no longer functional. At this point in time, it is just about 20 years old. It's basically defunct. Okay? So use an arithmetic sequence to determine the amount of the annual depreciation. So what I can look at is I can let T of n represent the value of the press n years after 1992, because that's when I bought it. So T of n, if T of n is the value of the press after 1992, that's when it was brand new. 5 years later, it's $311,000. So T of 5 would be $311,000. In 2010, it has a value of $2,900. Well, what term is that? So how many years after 1992 is 2010? 18. Now, we did a question yesterday like this, where we solved it a couple of different ways. We used systems of linear equations, but the other thing that we also found out is if I subtract, actually I should write it out. If I take T of 18 and subtract T of 5, and then divide it by 18 minus 5, I will get my common difference. That was using the arithmetic means. So if I take $2,900, subtract $311,000, divide it by 13, so when you put it in your calculator, if you're doing it all as one step, don't forget those brackets so that the calculator subtracts first. What do I get for D?
Negative.
What does the negative mean?
Doesn't just mean like it decreases.
It's decreasing. So the depreciation is $23,700 per year. Because I use the word depreciation, I don't need to put the negative sign in front of it. The depreciation implies the negative. So then if I wanted to find out what the purchase price was, in terms of my formula, what is my purchase price? Which variable would be my purchase price? A. A is my first term. My first term would be my purchase. So that's what I'm trying to calculate. What do I know about any of my variables so far? What's T? Or sorry, D? Okay, I know that D is negative 23,700. Do I know a T of n or an n? Okay. I can use this. If I let n be equal to 5, T of 5 is my 311,000. So I get 311,000 equals A plus, what's 4 times negative 23,700?
negative 94,800.
So then to get A by itself, I'm going to add by, so this plus a negative, let's simplify it and make it just a minus. So I'll add 94,000 to each side. What do I get? Okay. If you remember when we developed the formula yesterday, A is equal to T of 1. T of N is the value of the press N years after 1992, which means T of 1 is the value after the first year. So what would be the initial value, or the purchase price, I guess? Is the purchase price $405,000?
No, because that's after the first year.
So how do I get before that first year?
You add 25,000.
I add another year of depreciation, 405,800 plus another 23,700, and I get $429,500 would be the purchase price. So arithmetic sequences can be related to linear functions over natural numbers. I can't have, so my x values have to be natural numbers because my x's correspond to the term number. I can't have 2.5 terms. I either have 2 terms or 3 terms. So that's what that first statement means. So a pile of bricks is arranged in a row. There are 28 bricks in the first row. The number of bricks in each row is 2 more than in the previous. So if there's 28 in the first row, how many in the second? And in the third? And so on. So let's complete the chart all the way up to the first 10 rows. And I'll let you also graph them too. I would not join the points in this question because my R value represents the row, and I can't have a partial row. Is the range, so that's this, that's my output, is the range an arithmetic sequence?
Yes.
Why?
Because it's just adding 2.
Yes. So it's a common difference of 2. What is the domain of this relationship? What are my inputs? Okay, can it be anything between 1 to 10?
Oh, so just the natural numbers.
Natural numbers. So natural numbers from 1 to 10. does the graph not have an intercept on the vertical axis? Why can't I put a point here?
It's not terms for the
What does this represent?
term.
The term number, which is also in this case the row number. Can I have 0 rows? No. So I can't have T0 or 0 rows. So in part F, we're asked to write the equation of the number of bricks in a row as a function of the row number. So if I use my general form of an arithmetic sequence, because this is an arithmetic sequence, I can plug in my unknown values and then solve. So T of n is what I'd be trying to determine. What is the first term in this sequence? Pardon? No, the first term. This is my sequence. So the first term would be 28. So this would be T of 1 equals 28, T of 2 equals 30, T of 3 equals 32, and so on. So T of 1 would be 28. What was my common difference? So I get 28 plus 2n minus 2. And when I clean it up, I get 2n plus 26. So now if I substitute in the values that I'm supposed to have, write an equation for the number of bricks as a function of the row number. So this n here represents the row number, and T of n represents the number of bricks. So in the second row, 2 times 2 is 4, plus 26, I get 30 bricks in the second row, which corresponds to my chart. If you remember from last year, if I was to look at this graph, and it is a linear relationship, so if I looked at my slope y-intercept form, if I extended this line down, where should it cross the x-axis? Or sorry, the y-axis? At 26. That's my b value. If I look at the slope, each increment going up, rise over run, is 2. So it goes up 2 and over 1. So the slope is 2. And I get the same equation. Okay, your questions. 2, 5, 6.